Lecture 5, Section 2, Part 3. This is the last part of Section 2. Let's start with an introduction to just-in-time. Just-in-time actually has been invented by a Japanese firm after post-war. They had limitations on cash, so they were not able to invest in inventories. So because of that, the Japanese firms invented lean production. So anytime that we see the terms lean production or just in time and zero inventories, they are all equivalent terms, and they're talking about a production system with minimum of inventories. So in just in time, we do have two main components: Kanban system and SMED, or single minute exchange of dies. So in Kanban actually has been invented and used by Toyota for implementing just in time, and it's actually a card or ticket or somehow a manual information system. Okay, we can say the just in time is the evolution of Kanban system. So in Kanban system, we do have some cards and the information about the process, and the needs or requirements are recorded on the card, and then they will go through the process. So any update on the information will be recorded on that card. So it's actually a manual information system. Okay, and beside the Kanban system, just in time has the second component, which is single minute exchange of dies. So this capability allows the manufacturer to implement the model changeovers in minutes rather than hours. So this actually speeds up the production process, so they are able to implement the just-in-time philosophy. In this figure, you can see how the flow of information and data in the production process is conducted by using the Kanban system. Okay. So this is the formula that Toyota uses in order to obtain the number of Kanban tickets. So D bar here is the expected demand per unit time. L is the lead time, so including processing time, waiting time between processes, and also conveyance time. Okay, so if we multiply D bar by L, that will be the expected demand or requirement during the lead time. And the W here is the buffer level depending on our policy. So if we add up D bar L plus with W, then it will be the total requirement during the lead time, right? And then A is the container capacity. So if we divide the total requirement per lead time by A, so here we are assuming each container will have a Kanban ticket or a Kanban card. So by this, we can obtain actually Y as the number of Kanban tickets needed. Okay. So in order to comparing the just-in-time with the EOQ, let's see what's the difference between these two, and if the just-in-time is a replacement for EOQ or it can be an addition to EOQ. So for just-in-time, we know that we can't implement just-in-time in any circumstances. So yeah, I mean, in some circumstances where it's impossible to reduce the setup time, I mean, just-in-time is relying on SMED, which is reducing the setup time, I mean the time of changing the dies, very significantly. So anywhere if it's not possible to reduce the setup time, or because of the variability and uncertainty over the demand or production process, maybe it's impossible to minimize the inventory level from a certain level. So yeah, in those situations, maybe it's impossible to implement just-in-time philosophy. But let's see how just-in-time works. Just-in-time is relying mainly on SMED, right? Because of reducing the time of exchanging the dies. So when we reduce the time of exchanging the dies, this means we are reducing the setup time, right? So by reducing the setup time, actually we are reducing the setup cost as well, right? So if we reduce the setup cost in EOQ model, I mean the K in the numerator, then the value of EOQ decreases as well. So it will be smaller lot sizes, right? And this is the idea behind the just-in-time. So as you see here, the EOQ and just-in-time actually are on the same line, because you see how it works. If we reduce the setup time, this means we are reducing the setup cost, and this will reduce the lot size in EOQ. Okay, and another actually restrictions in just-in-time is the Kanban system. So it is a manual information system, so it's not efficient enough to update the sudden changes in the line. So if we replace the Kanban system with a computerized central information system, then we will be able to update any sudden change in entire system. Okay, so this is what we mean about the central information system, which allows the manufacturing environment to implement the just-in-time philosophy. Okay, just-in-time is most efficient when the demand pattern is stable and predictable. So, but we know that MRP works better in case of having predictable changes in demand. Okay, so yeah, changes in demand could be because of predictable causes or random fluctuations, or both, but just in time is not able to handle these changes. Okay, but MRP can actually handle the predictable changes in demand. Okay, so yeah, as you see, both methods could be unstable in case of high demand variance. Okay, another potential shortcoming of just-in-time is the idle times in case of unscheduled breakdowns. What does it mean? If we have a sudden breakdown in the production process, so since we don't have a large level of buffer in the production process, then all stations cannot continue working, so we'll have idle time. But in traditional systems, because of having enough buffer, even by having a breakdown in one workstation, other workstations can continue working. But in just-in-time, it's not. So yeah, but on the other side, we can say buffer inventories actually can mask underlying problems, right? But in the positive side, buffer inventories provide a means of smoothing production process. Okay, and in this figure, you can see a summary of advantages and disadvantages of just-in-time and Kanban system. Okay, so at the end, let's compare the lean production with just-in-time. At the beginning of this part, I said that these two are somehow equivalent, but if we want to be more precise, we'll see they are somehow equivalent, but there is a difference between these two. So both have same goal, which is reducing the work in process inventories to a bare minimum. But lean production is more than just in time. So yeah, additional to just in time, lean production has these features as well. So it's linked to Six Sigma quality program. It includes a cellular manufacturing system, the focused factory, and also total productive maintenance. So because of that, it's called lean production. Okay, so that's all about this chapter. And so in this chapter, as you see, the main focus is on MRP, and we just had an introduction to just-in-time, but we are not going to be more detailed in just-in-time. So yeah, our main focus in this chapter is on MRP. Okay, thank you.